I get some wonderful questions from students, and one is asking, in the unit circle, why is cosine theta just x? And why is sine of theta y? And in order to explain this, I think let's do some basic math first. Let me do just a few problems here. Let's do 5 divided by 1. Let's do 22 divided by 1. And let's do p divided by 1. Okay, so when you're done doing these, just unpause and we'll go over the answers. All right, well, hopefully you realize that anything divided by 1 is itself. So 5 divided by 1 is 5, 22 divided by 1 is 22, and p divided by 1 is p. We don't know exactly the value of p, but we know it's not going to change. So what does this have to do with the unit circle? Well, everything. Let's go and get a unit circle real quick. Now in this one, theta is 30 degrees. And once we create a 30, 60, 90 triangle, we know that there's certain properties. We know the short leg will be 1/2, and we know that the long leg will be √3/2. Now what do we know about the radius? Well, it's a unit circle, remember, so that radius is always going to be 1. Now remember from geometry that we did a little earlier, cosine is equal to adjacent over hypotenuse, right? Okay, so looking from this angle's perspective, right down here, what is adjacent? Or what's the length of the side that's adjacent? You're right, I can hear you. That would be √3/2. √3/2. And what's the hypotenuse? The hypotenuse is 1. And what is anything divided by 1, as we see up here? It's itself. So that means that cosine, and we are at 30 degrees here, so 30 degrees, is √3/2 divided by 1, which is just going to be √3/2. So see that we just get back to what x is. So I didn't want blue for that one. I specifically hit green because I wanted to change up my colors. Let's try that again. Okay. So that aligns with x. So that's why cosine is x. Now let's do a little further and let's look at sine. Remember that sine is, what's the ratio for sine? We just did this a couple weeks ago. Opposite over hypotenuse. Right. So now let's get a different color here. So looking from that angle's perspective, what's opposite? Yes, right there. The length is 1/2. So right here, 1/2. Opposite is 1/2, and the hypotenuse again is 1. And guess what 1/2 divided by 1 is? Right, it's 1/2. So sine of 30 degrees is going to be just 1/2. Once again, sine is the y value, and it's just 1/2 here. So it completely works out and checks out. Because we're always dividing by 1 in the unit circle, we don't have to, or we can simplify it each time to just x for cosine and y for sine. We're going to go play on an interactive unit circle, but notice when we do, take note of a couple things. It's going to give us the x value and the y value, and that x value will be identical to what we see here for cosine. It doesn't matter what I do with angle theta. I'm going to go beyond. Notice that at each point, the x value and cosine are the exact same. Because as you can see right there, we're just dividing the x by 1, and that'll always be the same. No matter if it's a really large angle, if we keep going, the x value and the cosine will remain the same. Now, the same thing's going to happen for sine. I'm going to switch to sine for a moment. Okay, now notice that for sine, you have the y value in the top row here, 0.581, and look at sine of theta, 0.581. That would continue all the way. Let's get to an acute angle. Let's get to angle theta of 60 degrees. Yeah. It's a little touchy here, 60, there we go. Notice again, okay, so we've got 0.866 in the y value, and sine is 0.866. So it doesn't matter where you go, you're always going to be dividing by the hypotenuse, which is 1 in a unit circle. Therefore, sine will always be just your y value, and cosine will always be your x value. Students also question, why is tan y over x, or we could say sine of theta divided by cosine of theta? Well, let's go back to what we learned about tangent a couple of weeks ago. Tangent is simply your ratio of the opposite, right, over the adjacent. So let's look at this one here with angle theta being 30 degrees. Opposites. So this is our angle here. Let me just central angle that we're measuring from. What's opposite? Well, opposite would be 1/2. And what is the adjacent? Well, adjacent would be √3 over 2. And we know we could simplify that. The 2's could cancel out. We would have 1 over √3. And then we have to rationalize, so we'll multiply them both by √3, which would be √3 over 3. And that would be the solution for that. So tangent is always opposite over adjacent, and in the unit circle here, the opposite will always be the y value, sine, and the x value will always be cosine. And we can see that here in the graph of tan, although it's not quite as obvious, unless I go to like 45 degrees and coterminal angles to 45, because then tan will be 1. You can see at 45 degrees right here. Oh boy, there we go. Y over x, that's because we are dividing 0.707 by 0.707, which would of course be 1. So at these 45 and all coterminal angles, so 135 would be the same. That would be -1 because cosine's negative, but sine is positive. Down here at, let's see, that would be 225. There we go. Y over x. Oops. Y over x there, it's positive because we are dividing a negative by a negative. And then 315, we're going to have 1 as well. It's not quite as obvious to see as when it's just cosine or sine, but that relationship is still there. 315, my goodness. There we go. And that's -1 because cosine is positive, but sine is negative.